The word radical is synonymous with unpredictability, progression, and excitement. In organic chemistry, radicals are molecules that have a single unpaired electron formed by a covalent bond. They occur when energy is added as either heat or light. Radicals have their own style of reactions, some of which are due to radical initiators. Radical initiators are compounds with weak bonds that produce radicals. The most common are peroxides and ROOR compounds. There are two main types of radical reactions, either with sigma bonds or when they're added to pi bonds. Both produce an octet of electrons. The first type occurs when a radical X reacts with a CH bond. This radical reaction is most common with CH bonds of alkanes, as they don't react with polar or ionic electrophiles and nucleophiles. It begins when a radical X takes a hydrogen atom from a CH sigma bond, which forms both HX and a carbon radical. After that, we add an electron from the CH bond. This forms the new HX bond, while the other electron in the CH bond stays on the carbon. Finally, the original radical X is surrounded by an octet of electrons, and thus a new radical is born. The second type of reaction occurs when a radical X is added to the pi bond of a carbon-carbon double bond. This one begins when an electron from the double bond is added to form a new CX bond. Meanwhile, the other electron stays. Because they're so electron-rich, the double bond of an alkene reacts with radicals because of how electron-limited their intermediates are. And once a radical is formed, it'll react with whatever it finds. So what happens when radicals react with each other? Usually they join forces to form a sigma bond. They can also react with oxygen, which is in itself a diradical. When this occurs, the reaction between oxygen and the X forms a new radical. In this case, oxygen stops X from reacting with an organic substrate. Compounds that behave this way are known as radical inhibitors or radical scavengers. When alkanes are exposed to halogens in the presence of either light or heat, they react to form alkyl halides. This is an example of halogenation. Halogenation is when a hydrogen atom is replaced by a halogen atom. It is known as a radical substitution reaction. Halogenation of alkanes can only happen with chlorine or bromine. With fluorine, the reaction is too exothermic and the product, HF, too volatile. And with iodine, it's too slow. When an alkane has more than one type of hydrogen atom, it may cause a combination of alkyl halides. This happens when a halogen replaces a hydrogen on the alkane, a process known as monohalogenation. It may also occur when you add halogen X2 to an excess of alkane. And just like a great plot twist, the turn from radical reactions to halogenation is another reminder to expect the unexpected when it comes to organic chemistry.